Okay, we continue. Okay, next we move into principle of something. Principle means something that do not change and defined by an equation. Yeah. So we now start to work into work and energy. We already define what is work. Work equal to force multiplied by distance traveled, which is both vector must be go parallel and same direction. If it's different direction, 180 different direction, then you get negative work. That is the general understanding of work. Now we involve energy. Yeah? So let's say you have a particle with a mass m subject to an external force represented by a resultant force of this one. Okay. So we doesn't care what are the individual force, but we sum up, we get resultant force of Fr acting on the particle. Once you have a resultant force, in the chapter 3 question, we always split into x and y, or direction of parallel to the direction of your movement, or normal to the direction of the movement. You know that on the curve, you have normal and tangent direction. Recall back, if there's a curve, then there will be a normal and tangent direction already. The tangent direction always follow the direction of motion, same as your Vt and Vt, right? And curve, to find the acceleration for your normal acceleration is v squared over rho. Okay, and this particle move at a certain distance ds. So the dotted line one is all the sum of the force in tangent direction and sum the force in normal direction. And the particle moving along the curve with its tangent direction. Recall back definition of work. Normal force do not create work because it is normal 90 degree to the displacement vector. Okay, this one, the Fn do not create work because the distance traveled along the curve with its tangent to the curve. Normal direction do not create work. Only tangent forces create work. You take force, multiply by the distance traveled, you get work. And it's positive work because it's follow the motion. Two vector arrow pointing together. What you can write is F equal to ma. And why we focus on tangent only? Because normal do not create work. So we know that it's a normal force, but in the context of principle of work and energy, Fn do not contribute anything. So we focus on the tangent, F equal to ma. So you know that the definition of derivation that we have, V equal to ds dt, A equal to dv dt, and you write this one dt equal to ds over v. This one you write dt equal to dv over a. So dt same, so you put them together. dsv equal to dva. So you move here and there. So a ds equal to v dv. Okay. And why we call out this equation? Because when we talk about work displacement is important. So we pull out the definition of A. Again, chapter 3, we only deal with force, displacement, and velocity. Acceleration, we doesn't care. So we move everything. A equal to V dV over ds. Substitute inside there. Okay, you put this one here and you move around. You will get F ds equal to mv dv. Make sense for you? Okay, and you know that when you see the d something, the next step is integration. Next step is integration. So integration, can you see the format after this? This one, integrate ds, you get fs, right? This side you get fs, right? This side, what do you get? M you cannot integrate. You pull out, M is a constant value. You integrate V dV, what do you get? V square divided by 2, right? So, and then you multiply M. Half mv square is what? Kinetic energy. This one we call back from physics, okay? You integrate. These are the integration steps. Put in the limit, upper limit, lower limit, S1 to S2 because you're integrating the S on the left. On the right hand side, you're integrating the velocity. So M is a constant value. Throughout this module, your M is constant. So M pull out. You're integrating the V. So V squared divided by 2. Substituting the value in. You get this. You'll get F ds equal half mv square minus alpha mv square and v2 minus v1. And you know that this form is kinetic energy. Okay, this equation is called principle of energy. And this one, we're dealing with when there's a velocity, there's a kinetic energy. From this equation, when there's object moving on the surface, there's a force parallel to the surface, the work done already. The work can convert into kinetic energy when there's a change of velocity. Yeah. So we are deriving from F equal to ma from chapter 2. Any question for this? Okay. Okay, so this one you just ignore it. But what I want to show you is this equation. F ds is work. So you write work position 1 to 2. This is, you need to memorize. If this chapter 3 question come out, automatic, you need to write this one on your answer sheet. You need to write sum of the work 1 to 2 equal to half mv square 2 minus half mv square 1. This one got 1 to 2 marks if you write this one out. And this is principle of work and energy. So if the question give you hints by using principle of work and energy, you write this equation. On the left hand side is work. Principle of work. So on the left hand side is work, right hand side is energy. Yeah. So actually quite direct the question. Usually you will see using principle of work and energy. So if the object moving with the velocity and there's a force, then left hand side is work, right hand side is your kinetic energy. And this one move in the straight line, in the path, or in the, you can say curve or straight line. And curve, you use tangent only. We focus on tangent. Normal do not contribute to work. Okay. So kinetic energy. So in short, you can memorize as T2 minus T1, but in the answer, if you write T2 minus T1, you won't get marks because T in the chapter 2 Pulley question is equal to tension. Yeah, so in chapter 3, then we use T equal to kinetic energy. It depends on chapter to chapter. Now, in chapter 2, pulley question, T equal to tension. In chapter 3, we use capital T as kinetic energy. Huh? E, E got, because energy, you have kinetic and potential later. So and then spring energy some more. So we don't want to, and then sometimes if you go into nuclear, then nuclear fusion energy and all this. Okay, but we don't go there lah. Okay. I want to highlight here, kinetic energy always positive. Why? Based on this equation, why kinetic energy always positive? If your V is negative, what happened to the equation? If V2 is negative, if V2 is negative, you bracket negative here, square, what do you get? So positive, positive lah. So kinetic energy, because got square, you always get positive kinetic energy. Yeah. Okay, the rest lah. So sometimes the question asks you to find the initial kinetic energy, or from the kinetic energy, you can find the initial velocity and so on. And then from here, you can move back to chapter 1. If the acceleration constant, then you use the V to calculate your distance, your and other timeline, time and all this. Okay. Okay, this is for the second section of this one. Okay, the rest you read. The rest you read. And then you can rearrange the equation depending on what you want to find. But it's still the same thing. Okay. Now is just now is the general principle work on energy. What about friction? Friction create work or not? Yes. Why? Because you have a friction force vector and the displacement of distance there. And friction always opposite of your motion. So the work will always negative. Okay, the rest, I think you can understand this one already. When there's a contact, then there's a normal force, there's a friction force, and the weight always pointing down. Okay, start from chapter 2, you need to, when the mass is given, you need to put weight in your free body diagram. It's either on top of the dot or below the dot. It depends. Both also can. So I can write my equation like this. It might be confusing to you, but basically, okay, this is wrong. My notation is wrong. It should be P multiplied by S. It's not the sub. Okay, means the principle of work and energy means work on the left. Right hand side is energy. So you know that when it's moved with the velocity, then you have kinetic energy. So you calculate on the left, you calculate work, means the force multiplied by distance, all the work, all the force. P is force, friction is force. So P multiply distance, friction multiply distance. So you have PS, and this is minus because the vector is different. Vector direction different. The mu K and S are also wrong. My sub S here should be big S. Should be the distance, because friction multiply distance traveled is your work. So wrong notation on my slides. And then you put MV2, half MV square 2 minus half MV square 1. You get the principal work of energy equation. Then you balance the equation. What is missing, then you find. Which one? This one is V2 minus V1 always. Yes. The end result minus early result means 2 minus 1. Okay. Okay, so you look at this example, then I think we stop after this example. Okay, so you're given an object with this, you see V already. Usually see V either is chapter 1 motion equation F equal to ma. Then if chapter 3, then principle of work and energy lah. So this is example 2 in chapter 3, but if it come out in the test or final exam, if chapter 3 question, you will see in the question applying principle of work and energy for your solution. Okay, you're given mass, travel down at a speed so and so. If driver jam the brakes or press the brake, causing the wheels to lock, determine how far the air skid on the road. Coefficient kinetic friction is given. You want to find how far the car skid, right? Like chapter 1 question actually. But in this case, you need to use principle of work and energy. Okay, free body diagram. Okay, I just draw on the slides lah. So you copy the object, you can as a big dot. First step is W pointing down. Then what else? Touching surface, right? So chapter 3 or chapter 2 onwards, you have to put in normal force. So in this case, because the question do not ask you which wheel, as you move later chapter, you need to identify which wheel, front wheel, back wheel. This one only you look at the particle, you still at the particle chapter. So only one normal force go up. Friction force opposite the motion, which is pointing that way. Okay, pointing that way because it's you pressing the brake, the car still moving to the front. So friction move to the back. Okay. Then you put in this is free body diagram. The green color velocity is your kinematic diagram. You want to put in A also can, but this kind of question, you don't require A lah. Okay. So you know the final velocity, right? Is 0. Okay. Causing the brake lock, determine how far skid on the road. Okay. Okay. Yes. Okay. So this is just a quiz question. If the weight is displaced S sine theta, or you can like W sine 10 lah. I mean on my slide here, we are slanting the surface lah. But in our previous discussion, we always follow the surface lah. Okay. It works anyway, any direction also. Right. So this one you read. Okay, why does the W create positive work? Why the weight create positive work? Because the X direction weight is following the displacement direction. The Y direction do not create work. Yeah? Normal force do not create work. Okay. So applying the equilibrium, you can find the normal force. You can apply equation of equilibrium that you learn in your statics, equilibrium. So all the force is normal equals 0. Chapter 3, you need to use start to use equation of equilibrium to solve something that you don't know. Chapter 2, you don't need equilibrium. But chapter 3 onwards, you need to start to use equation of equilibrium to balance the force. So in this case, in normal force, so NA go up positive, W go down. So from here, you can find your NA. Yeah. So I do not substitute, I just give you the answer. Then once you find the N, you can find the friction force. Okay. The equation of equilibrium is to help you to find Na. Why we need Na? Because you need friction force to find work. Friction force create work. And to reverse it, you need to find the normal force. Huh? Okay. Principle of energy, you can write T1 equal to work 1 to 2 equal to T2, or work equal to sum of T2 minus T1 also can. It depends. Huh? So as long as it's work and energy, why the equation put in this way is on the left is event before, on the right is event after. Okay, but you can put kinetic one side, work one side, no issue. Huh? Then you put in all the equation. Kinetic is half mv square 1. On the left, if you put on the left means before, all the parameter before. U1 to 2 is all the work done before and after. So work done is all the forces and the distance traveled. As long as you have the force, then there is, and go parallel with the distance, you have work. So W multiplied by the distance, mg sine theta multiply s, and then friction force multiplied by the distance negative. So the rest is substitution. You can find the distance is 5.76. Yeah, the rest is substitution. And why this one 0? Because when you press the brake, the object will stop. The V2 will be 0. This one also important. You need to either, you can use arrow, then once you arrow equals 0, or you can substitute this one 0. Either way also works. Okay. Okay. Then what else? Okay. This is chapter 3 answer, where the question force you to use principle of work and energy. Right? If the question come up for chapter 1, then you can use equation of motion. Okay? Equation of motion, you find acceleration. This is you go home and read. You can use equation of motion if the question allow you to use. If not, then you have to use chapter 3, principle of work and energy. So chapter 1, what you need to do is find the acceleration always and make sure it's the constant value. You need to make sure, check the acceleration is the constant value. Then only you can use equation of motion. You need to verify the A first, that is constant value. Then you call out anything that related to what you have. In this case, you have the velocity after and before, and you have the acceleration already. Distance you know, distance you need to find. So there's only one unknown there. You get the same answer. Yeah. So you need to know when you use, depend on the question. Okay. In chapter 3, then you need to use principle of work and energy. Okay. Okay. If we have time, we go example 3. If no, then we go to the next section. So we end our lesson here.